So how are we going to weight them? Well, let me show you how we weight them. It has to do with the alternative hypothesis. So this is the null hypothesis that we all discussed. The drug has no effect, and therefore the mean is 0. And we use 2.5% probability for type 1 error. That's here. And now, if we want to talk about what happens if there is an effect, we need to assume what the effect is. You need to have an alternative hypothesis. So I'm going to just assume, out of the blue, that the alternative hypothesis is that, yes, there is an effect, and the effect is at a mean of 2.5. 2.5 standard deviations. Okay? So that's the alternative. That's the effectiveness case. If that's the alternative hypothesis, then what are the chances that we might incorrectly reject the drug? Well, if we use this particular threshold, 1.96, but the alternative hypothesis is the distribution that we really need to be using, then the answer is we're going to fall short of that critical threshold under this new distribution here. So this is the type 2 error. This is the probability of a false negative. And so far, it looks pretty good. It looks like we're much more likely to approve the drug than we are to miss out on the drug, right? So there you go. You have the trade-off. Type 1 error is here, the area under this curve. Type 2 area is the area under this curve. And the trade-off, the ratio, is going to be the ratio of this to this. And in this case, what I just described, the area under this curve is about 30%. The area under this curve is about 2.5%. So the ratio is about 12. What it means is that I would rather let 12 effective drugs go free than to convict a single ineffective drug by approving it. That's the way to think about it. So that's the standard in this very, very simplistic case. All right? Type 1 error of 2.5%, type 2 error of 29.4%, and that ratio is going to be somewhere in that 12 range. And of course, typically we like to think in positive terms. So instead of type 2 error, we'd like to think about what's the chances of finding an effective drug, and that's 1 minus the type 2 error, or power. The power of this test is just this side of the curve, and in this case, it's just 1 minus 29%, or about 70% power. Okay? You've got a 70% chance of finding the effective drug, if it exists, of this particular kind. If this is the alternative hypothesis, your statistical procedure will be able to find it 70% of the time. That's pretty good. Now, that's because I assume that the treatment effect was pretty big. That is 2.5 standard deviations from the null. What if it's the case that we've got a relatively weak drug? So the effect is actually kind of small. It's kind of hard to see, right? You can tell with these two hypotheses that it's going to be very, very difficult for you to reject the null hypothesis because the alternative is right on top of the null. If you looked at type 1 versus type 2 error, there would be huge amounts of type 2 error in this case, right? So obviously, we need to make a decision on how to run the trial to do the best we can. One thing we can do to change the odds is to get more data. Because the more data we have, the tighter that distribution gets. So imagine if we actually increase the sample size by quite a bit. Let me show you what happens in that case. So here is example. This is the previous page's example. But what I've done is instead of having a standard deviation of 1, I've reduced the standard deviation to 0.1. I've reduced the standard deviation by a factor of 10. Now, that's clearly a case where I can easily distinguish between the null and the alternative, right? So I've got plenty of power in this case to tell between the two. How did I do that? How do you decrease the standard deviation by a factor of 10? Well, you have to increase the sample size by a factor of 100. So if you try to increase the sample size by a factor of 100, you've got to multiply 100 times your sample size times $36,500 per person. There's no way you can do this. It is way too expensive. And that's where the third variable comes in: size, power, and cost. We don't have infinite resources, so we have to balance all three of those considerations. And ultimately, when we design a trial, we're trying to balance those three.